Okay, we are moving on with binomial expansion. And what we're going to be doing this time is we're going to be solving for one of those binomial terms. So we're going to have to take some information that's given and kind of work our way backwards to be able to find it. So let's get started with that. With the first example, it says in the expansion of px plus 1 to the 6th power, the coefficient means like the number in front of a variable. So like if you have 5x squared, the coefficient is 5. That's all the word coefficient means. The coefficient on the x to the third term is 160. Find the value of p. So we're going to approach it this way. We know that it's a 6 up there. It's something to the 6th power. So I'm going to, for Pascal's number, put a 6. And I'm going to have px raised to some power, and we have 1 raised to some power. And we do know that the final answer, when all of this is going to be done, should equal 160 x to the third power. Now the important part here is right here. It says the final answer should have an x to the third power, and the only way we can get x to the third over here is by putting a 3 right there. And if this is a 3 here, then over here it needs to add up to 6, so that would also be a 3. And whatever this one is going to match down here, so that will also be a 3. And now we're going to simplify it. So we have 6 choose 3. You can type that into a calculator, and that equals 20. And if we have px cubed, what that means is px times px times px, it would be p cubed x cubed. And then we have times 1. Pretty simple there. And then we'll set it equal to 160x cubed. So I know that the exponents are going to match up. I can cancel out this x cubed and this x cubed. You could divide it on both sides if you wanted, but they just go away. So really what you're left with is 20p cubed equals 160. And then we end up solving for p. And to do that, let's divide both sides by 20. So you're going to be left with p cubed equals 160 divided by 20 is 8. And here's where maybe you forgot how to solve these. If you had something squared, let's say it was p squared equals 100 or something like that. To get rid of a squared, you just take a square root and then it does it for you. And there's always a button for square root on a calculator. But what about p cubed? How do you get rid of that 3? Well, what you're really doing, let's go back to the square root. What you're really doing when you take a square root is it's raising it to the 1/2 power. If you have 2 to the 1/2, that 2 times 1/2 becomes 1. And then you're doing the same thing over here, raise it to the 1/2 power. And so this 2 times 1/2 cancels out. Sorry, it got kind of messy. 2 times 1/2 is just 1, and you're left with p to the 1st power, which is what you're trying to solve for. And then 100 to the 1/2 is 10. So to solve this one, if we want to get rid of p to the 3rd, we can just raise this to the 1/3 power. And that 3 times 1/3 cancels each other out, and you're just left with p. So let's raise this to the 1/3 power. And coincidentally enough, 8 to the 1/3 power is just 2. So you can type that in a calculator. You can double check your answer as well. 2 times 2 times 2 gives you an 8. So that's how you end up solving. You kind of have to go backwards and then figure it out. So go ahead and try the next one on your own. Pause the video first and then come on back when you are ready. Okay, this next example that we're going to do, it's going to involve some bigger numbers. Anytime you're dealing with something to the 12th power, those numbers get really big really fast. So don't be intimidated by the big numbers, just trust the process. So in the expansion of 6x squared plus b all to the 12th power, the coefficient of x to the 14th is that big number right there. And then it says, find the value of b. So again, we're going to go through the same process where we set it up with the information we know. Since this exponent is a 12, we're going to start with 12 up here. And I'm going to leave this blank. And then this is going to be 6x squared, which will be raised to some exponent. We don't know it yet. And then this is going to be a b, which is also raised to some exponent. We don't know it yet. And the information they tell us is this term should end up equaling 216,513 x to the 14th power. So that 14 is very important. We want to make sure the variables end up as x to the 14th. Now you'll notice here, this is already an x squared. So in order to make it x to the 14th, we can put a 7 up there. X squared to the 7th power would make x to the 14th. Now if this is a 7, we know that they have to add up to 12. So let's put a 5 here. And if that's a 5, and then this is also going to be a 5. And now we just go through and we're going to solve for b. So first we will start with 12 choose 5, and that's going to equal 792. And then we do the 6 to the 7th power, so 6 times 6 times 7 times, and that's going to equal 279,936. And then it's x to the 14th times b to the 5th power. And when all is said and done, it should equal 216,513 x to the 14th. Now what we can do is we can just cross off those x to the 14ths. We know they're going to cancel each other out. So go ahead and do that. And then you can multiply this mess over here on the left side. So if you take 792 times this big number here, I'm going to write it over this way. We end up with 221,709,312. b to the 5th equals, sorry, I run out of room again, 216,513. And we're trying to get b by itself, so we have to take this big number here and divide it on both sides. So you're going to divide both sides by 221 million and the rest of it. And if you do that, it's going to be left with b to the 5th equals 0.0009765,625. And here's the very, very last step. To get rid of that 5th power there, hopefully you remember, we raise it to the 1/5 power. And we're going to raise this one to the 1/5 power. And if you do that, you end up with b equals 0.25. It would be 1/4. So there's your value of b. There's no rule that says b has to be a whole number. It could be a fraction too. So we just found that b was 0.25. So go ahead and try this next one on your own. It's once again very similar. And then come on back for the last example. All right, we're on to our last example. Don't cry. I know you're sad that you're almost done. But don't worry, we've got lots more math to come this quarter. Next one says, find the value of a if the coefficient of x to the 11th is 15. So let's go ahead and start with what we know. We are going to start with a 10 for our Pascal number. We can write out our first term here, which is x squared. We write out our second term, which is 1 over ax. And when all is said and done, it should equal 15x to the 11th power. So here's where I've talked about before. This is kind of like a puzzle. Well, we have to figure out how this puzzle works. We need to somehow make the exponents cancel out in such a way that we're left with x to the 11th. So it might involve some guess and check. Let's go ahead and try an 8 here. If I put an 8 there, they have to add up to 10, so this would be a 2. And if you do this, x squared to the 8th power would give you x to the 16th. And on the bottom, you're going to have over x squared. And then 2 of those would cancel, and you get x to the 14th. Oops, that didn't work. So since that one gave me x to the 14th, I know it's got to be smaller than that. So I'm going to try a different combination. And because I know the answer, I'm going to try a 7 and a 3. And let's see what happens there. When you have a 7 and a 3, that first one would become x to the 14th. And on the bottom here, it's going to be x cubed. And then you'll notice 14 on the top, 3 on the bottom. 3 will end up canceling out, leaving you with what we were looking for, x to the 11th. So that's the combination we're going to be using, is a 7 and a 3. Now remember, if this is a 3, then this is also going to be a 3. So now let's go ahead and simplify it now that we have all the pertinent information. 10 choose 3. Simplify that, and it becomes 120. X squared to the 7th power is x to the 14th. And this next one, if you have 1 over ax to the 3rd, well, 1 to the 3rd is just 1. And on the bottom, it's going to be a to the 3rd times x to the 3rd. And over here, it should equal 15x to the 11th. So we're going to simplify this a little bit. X to the 14th on top, x to the 3rd on the bottom. We can write this as 120 x to the 11th over a to the 3rd. So that x to the 14th, x to the 3rd just combine to become x to the 11th. And now we know that the x to the 11th on both sides, they just cancel each other out. So we're left with 120 over a cubed equals 15. And now we just have to solve for our a. Easiest to just multiply both sides by a cubed, because then they go away and it's no longer on the bottom. So we have 120 equals 15a cubed. Divide both sides by 15. And what do you know? We end up getting 8 equals a cubed. And we know to get rid of that cubed, we can raise it to the 1/3 power. And we saw this one already. A is going to equal a 2. You'll notice when you're solving for missing terms like this, usually we make the answers work out pretty nice and easily. So you've seen a 2, you've seen it equal a 0.25, and you've seen it equal another 2. So usually the answers are going to work out pretty well in your favor. If you get some really, really goofy number, you probably did something wrong. Go back and check your work. So that is how to solve for a missing term. Hopefully it made sense. And there is one homework assignment, so go ahead and finish that, and then you are done for the week. Have a great weekend, everyone.